I welcome you for this next video in the machine learning model development series. Okay, so as of now, we are doing the data pre-processing. Okay, we did few data pre-processing over here where we just fixed the missing values but with the simple imputation. Now, as a next step, we have to use this data to build a classification model. All right, so let's go ahead. Here we had used imputer. And okay, so we had used two kind of imputer. Okay, one is your most frequent, other is your mean, right? So here it's impute using most frequent, I should write. Okay, most impute using most frequent over your frequent value. Okay, impute using most frequent value, right? And then using simple impute. Okay, and this guy is doing what? Imputation is getting done using mean value, right? So here we are impute using mean value. Okay, so this is a little update that we need to do, and then we will do this thing in the next step. All right, so then now we will do over here the next step, which says that we need to see we have an applicant and co-applicant income. So for the loan approval, instead of considering both the income separately, we can just consider them in a single unit, right? That okay, whatever the applicant and co-applicant income comes, we can just sum these things up, and then we can decide whether the loan should be approved or not approved. All right, so we can do over df applicant over here, that is your applicant income. All right, this particular thing will be added up with what? The co-applicant income. All right, so here we have a co-applicant income. Okay, I'll just copy this unit and I will paste it over here. So my co-applicant income, and then after I can update that particular column. All right, done. Now let's try to check our df.head. Okay, let's say I'll use 3. Okay, so I'll check it in the next cell to be better, otherwise this cell may be executed for multiple times. Okay, all right, so now here I getting the error because I have to execute everything once again. So I'll run and I'll do what? Run all sales. All right, okay, so here we are having applicant income sum up with the applicant income. So we have, now we can do what? We can remove the unnecessary data column before performing the encoding, right? So obviously we perform the encoding, but encoding we can do after this. Okay, after this guy we can perform the encoding. All right, and here we can perform what? We can just remove the unnecessary data column. What are the unnecessary? Like for example, loan ID. Loan ID will not decide whether your loan will be approved or not approved, so we can just drop it. Okay, so what I have to drop? I have to drop loan ID first, and second thing that we have to drop is what? Let's see, co-applicant income. Because already co-applicant income is added into the applicant income. Next, anything else that we have to drop? I don't think, all are looking good. And then we can define what? We can just define axis is equals to columns, because these guys are existing here in the columns. Okay, and this will be our new data frame. I can use now df1 as well if I want to keep df as it is, right? So df1 dot head. So I remove all the something is missing over here. This bracket is missing. Okay, so I remove the column which is not required. All right, now we can perform the encoding. So which encoding we can perform? Encoding we can perform according to the situation, right? Like for example, if I have ordinal data, we perform label encoding. If we have a nominal data, we can perform what? Or one hot encoding. All right, so here the data column that we have to encode is gender. Gender is already male and female, just 2 category. So we can use simple label encoder 0 and 1. Married, 2 category. Label encoder is we can do. Dependents, right? So dependents, if you check it over here, dependents. Okay, DEPENDE. Okay, dependents, right? And dot unique. So here we have 4 categories, right? But it is what? Ordinal. So we can use 0, 1, 2, 3 as encoder value. Education. What we have? DF education. Okay. So most of it, education is also having only two categories, right? So if two categories are there, we can use label encoding. Self-employed, yes or no, just two categories, right? Career history. Career history is already a numerical, but still we can check it. Career history. Okay. Dot unique. Okay, so career history is having over here 3 values, but it is already numerical, so not required, right? Then after property area. So property area is something which you can consider as a nominal as well as ordinal. Okay, let's check it out. Property area. Okay, so property area, urban, rural, and semi-urban. We can consider it ordinal. Okay, rural, urban, and semi-urban kinetic. So we can use simple label encoding. So here there is no need to perform any one-hot encoding. For all the data column where you have to perform encoding, we can use simple label encoders, right? So to perform label encoder, what can we do? First of all, we need the data column where we have to perform the label encoder. So if you see over here, we have a numerical and non-numerical columns. So we have to perform it on the non-numerical columns. Check it out. So loan ID and dependents we had already removed, right? So we can, since it is a list, we can do what? We can just remove it from here as well. Dot drop, or you can say dot remove. Okay, what I have to remove? I have to remove loan ID. And I also have to remove from here. Okay, everything is fine. Gender, married, dependents, education, self-employed, property, loan. Okay, so these guys we have to use, right? So now again I'll print it. Non-numerical columns. Right? So if you see these columns, we have to encode. So for encoding it, what can we do? The library already we imported at the very beginning, right? Label encoder. So we can just run a loop over here to do the encoding. Or we can use map function as well. That's depending upon you for kind of a columns in non-numerical columns. Okay. So I have to just encode each column one by one. So what I can do, I can just define first the object of label encoder. Label encoder. So now once we have an object of label encoder, we can do what? We can just use le.fit transform. Okay, what I have to transform? I have to transform over here df1, because my data is now in df1, right? Here we can, so df1 is same, it's like fine. So I can just use df1 over here, df1, and then I can pick up the data column. Okay, so it will get transformed, and then after I can update that particular data column that I want to update. Okay, so here it's like transform like this. Okay, so once we update it, things will be done, right? Now let's execute this guy and let's check it out once. df1.head 3. All right, now everything is done. Now log transformation of the numerical column. So for numerical columns, how can I access numerical column? These are my numerical columns, right? So here we have to perform what? Log transformation. Why do we perform log transformation? In case if any particular value in any column is not distributed normally, okay, that is one reason. Second, log transformation also help you in scaling down the values because your magnitude is larger. So the log transformation scaling will also be done up to some extent, so that processing or optimization can be faster. Okay, and if it is not distributed normally, it can be like normal distribution can also be done with the help of log transformation. So for doing the log transformation, what can we do? We can just call it over here df1. Okay, numerical columns. Okay, so this is a numerical columns that we have. Okay, so I'm getting some error over here. Why am I getting error? Co-applicant income is not in the index. Okay, so from here also I have to remove co-applicant income, numerical columns dot remove. Okay, what? Co-applicant income. Change numerical. All right. Okay. Now let's access this guy. Right. Now I can do what? I can perform log transformation easily by using what? np.log Done. And once it is done, we can do what? It is showing some warning that we can ignore as of now. Okay, and then I can just update this particular data column easily. Right. So once I update it, thereafter I can again check this thing. df1.add. All thing are done. Now we can do what? I can just separate the features and labels, right? So x is equals to what? Let me write the comment as well. Separate features and labels for creating ML model. Okay. So x is equals to what? df1.drop. Okay. What I have to drop? I have to drop loan status as a target column. Okay, and here I can say axis is equals to what? Columns. Okay, and then y is equals to what? df1 loan status. Okay. Right. Now it is done. Now we will do data scaling, but before performing the data scaling, let's do one more thing, which is called split into train and test. Okay. So from sklearn dot model selection, import train test split. Okay, I hope you know these things, these basic things. In case you don't know, then I will come up with more details using the machine learning, where each thing I'll explain in a very deeper way. Here, the purpose is the deployment, okay, or understanding how can we use our machine learning model at a production level. That's why, I'm not going into these things in deeper, like what is splitting, how splitting happens, and how these functions works. Right? For that, I'll just try to have a next video that I can share with you. Now here I can use x comma y. Okay, and then I can see train size. Let's say the training data I want to keep 78%. Okay, it's whatever you want to use, you can use. Okay, and random state to log the randomness. Okay, random state is equals to what? Let's say 0. All right, done. Okay, now we can perform the data scaling, right? So all right, so let's try to perform a scaling. So for scaling, we can use what? Min max scaler, right? So it's like from sklearn dot preprocessing, import min max scaler. Okay, here I can define an object for same. Okay, a scaler is equals to what? Min max scaler. Okay, and thereafter scaler dot fit what? Xtrain. Okay, and then we can do what? Xtrain scale, scaled, scale, and xtest scale. Okay, so here we have a scaler dot transform xtrain. Okay, and then scaler dot transform xtest. Okay, so the scaling will be done, but it is raising an error. Let's try to understand why it is raising an error. Let's see, input x contains infinity. So why it is containing infinity? It is because when we are performing over here, log transformation. Okay, so for log transformation, we are using these columns. Out of these columns, there is a column called credit history. Credit history is having few value as 0. Okay, and for 0, if you will do the log transform, okay, you will get what? Infinity, right? That's why we are getting an error, right? So to fix this error, we can do what? There is no need to perform the log transformation on credit history, because credit history is having just 3 categories. Okay, so we can just avoid it by using numerical columns dot remove. Okay, what I can remove? I can remove from here credit history. Okay, now once it is done, let's do one thing. Let's run everything, and then it might work. Okay, so things work now. Now I have to train my model. So for training the model, we can do what? From sklearn dot linear model. Okay, import logistic regression. Okay, so using logistic regression, which is an algorithm used for classification, we can train our model, and then we can define the object for it. Model 1 is equals to what? Logistic regression. Just few steps left, right? And then model 1 dot fit x train comma y train. Now we did the things. Here we are getting an error because I have to give it properly x train scaled and y train. Once it is done, then we can evaluate. So for evaluating, we can do what? Print accuracy. Okay, accuracy on training data. So training data accuracy is what? We can just see model 1 dot scope x train scaled comma y train. This is a accuracy on the training data, which is coming out to be close to 80%. That's good. Same thing, let's try to identify the accuracy on test data. So for test data, we can use x test, scale and y test. So it comes out to be close to 80%, right? So it's good. My model is performing with an accuracy of 80%. Next topic, we have to understand serialization, which means saving our model for the deployment, and deserialization so that we can load back the model. So serialization and deserialization is the next topic that we will discuss, saving and loading back the model. Till then, just complete up to here. If you find anything complicated, anything you can't understand, just pin down in the comment. I'll try to explain that part again by creating a new video, a new video in which I can explain all those things which you want me to explain. Thank you everyone. Have a great day ahead. We'll meet in the next video. Take care.